What's going on, guys? This is Mr. Martin. Welcome to 1.3 Algebraic Properties. If you look at our objective today, we're going to be talking about how to use these algebraic properties and determine if expressions are equivalent. Maybe they might not be. We're trying to see how to make these true statements. If you look down here, we have the standards that we're covering. And then we also have the Engage New York materials that we're going to be grabbing this information from. So we're looking at Module 1, Topic B, Lessons 6 and 7. So let's go ahead and jump into it. At any point, if you need to pause the video to write some stuff down, please go ahead and do so. We're going to fly right through this. All right, so the first things that we need to know is a little bit of vocabulary. We have these things called numerical expressions. So this is a mathematical statement that consists only of numbers and operators, and you might have some examples like 3 plus 8. Maybe you have something like 10 minus 2 plus 4, right? It could have as many terms as long as there are no variables and it's just these numbers and these operators. So the next thing would be an algebraic expression. Okay, and what this means here in algebra is that we are going to consist of numbers, variables, and operators. So now we're just adding a couple variables to the mix. So you could have something like 3x plus 5, and you could have something even as simple as 7x to the third power. Okay, so there's a variety of different examples. The other thing that we need to know are our like terms. You're going to hear me say this often, combine like terms. And what that means is that we have terms whose variables and their exponents are the same. So you might have something like 3x squared plus 2x squared. If we combine these, we are only combining the coefficients, right? Our variables are the same and our exponents are the same, so we can go ahead and combine these two. So this would look something like this. This would be the combination of our like terms. All right, so there's one thing on here also that I need you guys to know, and this is our giant list of properties. Okay, I'm not going to go through all of them with you. I'd like you guys to, either pause the screen, take a look at them, or look at them on your guided notes. But these are going to be our main algebraic properties. And as you can see here, the ones that are using the variables only, this is what we call our generic definitions. This A and B, or even C sometimes, is just saying for some number here, could be any number that we want to substitute. If you look here at the left in green, we actually have some numerical examples of what this property is telling us. So for example, the commutative property, and this only works with addition and multiplication. So it says, like, if I have some number 6 plus some number 7, I can go ahead and switch the order of those two numbers and I'm going to get the same result, right? 7 plus 6 would give me 13, as well as 6 plus 7 giving me 13. Okay, so go ahead and take a look at each one of these properties and their examples and kind of get a feel for what's going on. The other properties, in addition to these, are going to be our inverse identity property of multiplication. And then we have a few here, like the reflexive property, symmetric, and transitive. And they got some nice little definitions here that tell you how we use these properties. And these are generally used for when we write some sort of proofs to prove that we have equivalent expressions. So take a look at these again. I know I'm saying it a lot, but it's really important that you guys actually do take a look at them. All right, so let's go through a few examples here. So example number 1, I'm asking you to write a true or false for the statements below, and then identify which property is used. So looking at letter A, let's do this in red. We have 7 minus 4 equals 4 minus 7. Is this a true or a false statement? Well, if you take a look, what would 7 minus 4 be? That would give us a positive 3, and 4 minus 7 would give us a negative 3. So indeed, This is false. We cannot use any of these properties to justify an equivalence between these two expressions. Letter B, we got 2 plus the quantity of 3 plus 1 is equal to the quantity of 3 plus 2 plus 1. So what does it look like we're doing here? We have some sort of grouping. So if you go back, let's actually crunch these values out. 3 plus 1 would give me 4. 2 plus 4 would give me 6, correct? Same over here. 3 plus 2 would give me 5. Plus 1 would give me 6. So it does look like 6 equals 6. But we need to know what property is being used. So let's do this in green since it's true. So we know this is a true statement, and if we look back to our properties, when we know that we have some sort of grouping involved, this is our associative. One mnemonic device could be thinking about who do you associate with, what kind of what kind of groups are you in? Are you in the sports group? Are you in the academics group? Things of that nature. All right, looking at letter C, we got x plus 2 is equal to 2 plus x. This one is also true. All we did was change the order, and since it is addition, it looks like we could do that. This is our commutative property. Remember, always listen to what I'm saying. Sometimes my handwriting might not be so good. Looking at this one, we got x minus 5 is equal to negative 5 plus x. This one looks a little tricky. Maybe it's kind of like letter A because we got some subtraction going on. But it is actually true. All we did was change the order of the terms. If you look here, we have a positive x and a negative 5, as well as a negative 5 and a positive x. So again, this is our commutative property. Then letter E, we have 3 times the quantity of 9 times 5 is equal to 9 times the quantity of 3 times 5. Here again we have some grouping. So this one appears to be true, and we are using the associative. And what about this one? This is saying the quantity of a plus b squared. So this is our combination of a plus b squared, and this one is telling us a squared plus b squared is what it is equal to, and that is actually false. A plus b squared is not a squared plus b squared, and you guys will see that here in a little bit when we start doing some more of these problems. Okay, moving on. Example number 2. This is asking us to choose the properties that apply to complete this proof, proving that the statement is true. Letter G, we have our statement. X plus 2 plus x is equal to 2x plus 2. So let's start with, we're trying to find what this is equal to right here. So if we're starting with our left side, our expression on the left, we have our given x plus 2 plus x. And then the second line, what is actually changing here? Well, we got the x plus on the left side, that's remained the same. It looks like we had some movement of the order of the terms right here. So that is going to be our commutative property. Commutative. All right, and then you see that the grouping has changed, right? This x is now grouped with the other x. So we have an associative property here. And then what did we do with these two x's? We added them together, so we actually combined like terms. I'm just going to abbreviate this CLT for combined like terms. All right, letter H, we got this given. You know what? Why don't you go ahead and pause the video here? Try this one on your own, and let's see if we get the same solution. All right, welcome back. So hopefully you got the same thing that I did. What we did here was we actually distributed this 5 into this grouping of this a plus 5. Remember that we are going to be multiplying, so we could do this little rainbow trick right here. I'm going to show you another method shortly, but this one's the most common one used. Remember, it's always multiplying, and we include the signs, so we have 5 times a positive a, which is a positive 5a. 5 times a positive 5 gives me that positive 15. So we did our distribution, and then it looks like the 2a moved closer to the 5a, switching spots with the 15. So that is our commutative property, and then we ended with the 7a by combining like terms. All right, very good. So I have several examples here that we're going to go through. I'm going to do 1 or 2 of them with you, then I'm going to have you do some on your own, in which you would pause the video and then see how well you do. All right, so I'm assuming I should do the one with the fraction first, right? Since you guys hate fractions and probably want to see it done. Remember, this is going to distribute inside to both of these terms. So this is what we call the little rainbow or arrows, however you want to call it. But we are multiplying from this term that is outside of the parenthesis into both of the terms inside. So if we have a positive 2/3 times a 9x, remember, we can simplify this by dividing this number by the numerator, or you can multiply this number to the numerator and then divide by the denominator. Either way works. I like to do the division first, so I'm working with smaller numbers. So I ask myself, how many times does 3 go into 9? That's 3 times, and then multiplied by the 2 up top. So that's going to give me a 6x. 12 is divided by 3, which gives me 4. 4 times my numerator will give me a positive 8. So this is my solution. All right, I'll go ahead and let you pause the video here. Go ahead and try doing the rainbow or arrow method, right, like I'm drawing here, and see what it is you can come up with. Okay, welcome back. So if we go through letter J, what I did here was I multiplied the negative 9 to the 8. That gives me that negative 72. And then also a negative 9 to the 6p. Remember, when you multiply a number times a number with a variable, you are multiplying the coefficients and you are keeping that variable. So the negative 9 times the 6 gives you that negative 54, and you keep the p. Same thing down here. Remember, the signs are always distributed also. So if you have a negative 2 times this negative 8, remember that your negative and negative equal a positive, giving you that value of 16. Here we actually have a variable times a variable, and remember, you need to use your exponent rules. If you have a same base multiplying, remember that you add the exponents. So we have a exponent of a 1 and an exponent of a 1. Adding those together gives me that m squared. All right, so we also have what we call the box method, okay? And this is where you can create a little box, right? Draw a box of some sort. Now, depending on what is multiplying into the parentheses, right, is how big you want your boxes to be. The value on the outside, we only have 1, so we're only going to have 1 row, and we're going to place our value on the outside. And then we have 2 columns because we have 2 terms here, 1 and 2. So we're going to keep the sign with our term, and we're going to put them above each of these columns. And now we are going to multiply our outside term to each of our inside terms. So we have a 2 times a negative 9b, which is a negative 18b. And we have a 2 times a positive 2, which is a positive 4. Okay. So you might want to keep those signs. Oops. Positive 4. And then you can rewrite this out for your solution. These parts in the boxes will be our solution. And remember, the order does not matter, right? As long as those signs stay the same, because that would be our commutative property. So you could have a positive 4 minus an 18b. This would be the same thing. All right, go ahead and pause the screen here and try these next 3 and then try and match them up to my solution. All right, so hopefully you got the same solutions that I did. Take a look at these, check back, see where maybe you got anything wrong if you did, or if you got them right, fantastic. So it's up to you whether you want to use the rainbow or the box method. All right, so now we have simplify each expression using the distributive property, and then combine any like terms if possible. So like the others, I'm going to walk through one of these with you. I'm just going to do this here. 4 times 1 will give me a 4. 4 times a negative 6 is going to be a negative 24b. And then I have the minus 8b. Okay. These are my 2 like terms. Remember, the signs that are next to them. I have a negative 24b minus an 8b, and that is going to give me a negative 32b. So this 4 comes down. I cannot combine it because it does not have the same variable. And I am left with the 4 minus 32b. Okay, simple as that. All right. Pause the video here, try these out, and let's come back. All right, good to have you guys back. So I worked out the last 3 for you here. If you look at the bottom 2, this one and this one, they actually have 2 sets of distribution. And if you haven't already noticed the pattern, when we distributed twice, we actually had 2 different sets of like terms. So we had 2 variable terms that are alike, and then we had 2 non-variable terms, just like we did here. So I kind of grouped the variable terms together with the green, and then the blue showing the non-variable terms. All right, so that's it for our properties. Go ahead and attempt the practice. You will see this stuff again, so it'll be good to get good at it. If you have any questions, please let me know. Thanks.